Today we are checking out lesson 12.3. So we're still using the Pythagorean theorem, but this time instead of finding the length of the hypotenuse, we are going to be given the hypotenuse and use that information to help us find one of the leg lengths. So let's dive in, and we are really just using the same process in a different way. So before we used the Pythagorean theorem to find the hypotenuse of a right triangle because we knew the lengths of the legs. But we can also use the Pythagorean theorem to find the length of a leg if we know the other leg and the hypotenuse. So you will recall that Pythagorean theorem only works with right triangles. And our shortest side we're usually going to call A. Our medium length side we're going to call B. And our hypotenuse is always C, and it's always across from the right angle. It's always the longest side in a right triangle. So here's how it works. We're going to start by writing our formula, substituting what we know, and simplifying and solving, just like we always do. So my formula is A squared plus B squared equals C squared. I know that this is my hypotenuse because it's across from the right angle. So I'm going to call this C. My shortest side is A, and this side right here is B. So I don't know A, so this remains A. But for B, I can substitute in 12. So we're going to have A squared plus 12 squared equals C squared, and C is 13. So now I can simplify. A squared has to stay because it's unknown still, but 12 squared is 12 times 12, which is 144, and 13 squared is 13 times 13, which is 169. Now I need to solve for A, so I need to get A by itself. So to do that, I'm going to subtract 144 from both sides, and that leaves me with A squared. On the left-hand side, so remember we're down to using inverse operations, and on the right-hand side I get 25. So my next step then is to solve for A, so I need to get rid of my exponent of a 2. So to get rid of the squared, I need to take the square root. Remember that undoes that exponent. And the square root of 25 is 5, so I know that this missing side length must be 5. So 5 meters. Let's try that again with this triangle so we can see how it works on a different one. So I'm going to start by writing my formula. Always, always, always. A squared equals B squared plus C squared. Now on my triangle, I'm going to find my hypotenuse. It's across from my right angle. So this is going to be my C value. This looks to be my shortest side, so I'm going to call this side A. And this time B will be my unknown side length because it's not labeled. So I'm going to substitute into my formula now. I can put 9 in for A. I still don't know B, but I do know C. So I have 9 squared plus B squared equals 15 squared. Now I'm going to simplify. 9 squared means 9 times 9, which is 81. B squared, I can't do anything with yet. And 15 squared means 15 times 15, which is 225. So now I need to solve for B. So I need to get rid of the 81, and then I'll get rid of the exponent here. So to do that, I'm going to start by subtracting 81 from both sides. Remember, when it comes to equations, whatever we do to one side, we have to do to the other as well. So this leaves me with B squared equals 144. Now to get B squared down to just a B, I'm going to take the square root of both sides. The square root of B squared is B, and the square root of 144 is 12. So 12 is my missing side length here. All right, we'll do one more together before you try one on your own. Again, to find missing side lengths and use my Pythagorean theorem, I start by writing my equation. A squared plus b squared equals c squared. Now I'm going to substitute what I know into this equation. So first I'm going to label my hypotenuse because it's across from my right angle. So this is C. This looks to be my shortest side, so I'm going to call that A. This one that I don't know, I'm going to call B. So as I substitute, I'm going to put 10.5 in here for A, so I have 10.5 squared plus B squared equals 17.5 squared. Now I'm going to have to grab my calculator here to simplify because I don't know 10.5 squared off the top of my head. But 10.5 times 10.5 is 110.25. E squared remains the same. And 17.5 squared is 17.5 times 17.5, which is 306.25. So notice I didn't round these at all. I put the full exact value for these, and now I'm going to try to isolate b squared and then simplify it to just b. So I'm going to get rid of or subtract this 110.25. Whatever I do to one side, I have to go ahead and do to the other to keep my equation balanced. So on the left-hand side, all I have left is b squared. And on the right-hand side, when I subtract, I get 196. So when I take the square root of both sides, that is going to help me turn a b squared into just a b. Because squaring a number and taking the square root of a number are opposites. So now I need to take the square root of 196, which is 14, and that is my missing side length, which goes right here. All right, it is your turn to try this problem here. You can pause the video and work out the question and put your answer in Edpuzzle. Make sure that you show all your work on your note sheets. Okay, now we wrote over our question a little bit because my pen's too big, but if we want to know what is the length of the unknown leg of the right triangle, then these three examples that we just worked are going to show our method and process. So this is what your work should look like here. So something that you will begin to notice as you start working these is that there are some very common dimensions of right triangles that we'll see over and over and over. And we call these Pythagorean triples. So a Pythagorean triple is a set of numbers that make this equation true. It fits this a squared plus b squared equals c squared pattern because not all numbers will, but there are some common a, b, and c values that will always make this true. And we call those Pythagorean triples. So a couple of very common Pythagorean triples, you will have what we call a 3, 4, 5 right triangle. You can also have a 6, 8, 10 right triangle. And you can have a 9, 12, 15 right triangle. So take a look at these three different Pythagorean triples and see if you can find something that they have in common. What is the relationship between 3, 4, 5, 6, 8, 10, and 9, 12, 15? Then we're going to use that idea, the relationship or pattern that you find, to make a conjecture, where you're going to make kind of a prediction based on the pattern you see here. So in other words, how can we use that pattern? That's what our conjecture is going to tell us. Okay, this will be a discussion point in class that we will work through together. Let's check out our last couple examples. The length of the diagonal of a television screen is 42 inches. The length of the bottom of the screen is 36 inches. To the nearest tenth, what is the height? When you go to buy a new TV and you're looking at, say, a 63-inch TV, the 63 inches refers to the diagonal. That's how they measure the size of a TV. So this is a very common mathematical calculation that is made in manufacturing TVs. So let's take a look. What we know is that this forms a right triangle, so I can use Pythagorean theorem. So I'm going to start by writing my formula, a squared plus b squared equals c squared. And now I'm going to substitute what I know. The first thing I know is that this is the angle, or the side, across from the right angle. So this is my hypotenuse, my c value. So I can substitute that in for c. The height looks to be my shortest length, so I'm going to call that A. So it's still unknown. And B is going to be this medium length, which is 36. So I've written my equation, I've substituted the values that I know, and now I'm going to simplify and solve to find the value that I don't know. So 36 squared is 1,296. And 42 squared is 1,700, 64. Now to solve for A, I need to subtract 1,296. Whatever I do to one side, I will do to the other. So that leaves me with A squared over here and 468 over here. So as I'm solving this now, I need to solve just for A. So to get rid of the squared exponent, I'm going to take the square root. Whatever I do to one side, I do to the other. And the square root of 468, this is not a perfect square, so I'm going to get a decimal that I'm going to have to round. So I'm going to say A is approximately equal to, and I'm going to round this off here to the nearest tenth. So the height of this TV is about 21 6/10 inches. All right, and now it is your turn to try this one. In your notes, show all your work and you can answer in Edpuzzle. And next we are going to take a look at a very, very beautiful place. I don't know if any of you have been fortunate enough to visit, but this is on my bucket list. The entrance to the Louvre Museum in Paris, France is a square pyramid. So obviously it's a pyramid because it comes to a point and has these triangular faces, but it's a square pyramid because the base is a square. So we want to find to the nearest tenth the height of the pyramid. So what we're going to do is inside this pyramid, we are going to envision dropping, oops, sorry about that, dropping a line from the very top, from the vertex of our pyramid, straight down to the center of this square base. So when we do that, this is going to form a right angle with the ground, and this is going to give us the height of our pyramid. This is the value we're trying to find, the height. Just like when you go to the doctor and you get measured, they measured your height, they have you stand perfectly straight up and down to get an accurate measurement of your height. In the same way, the height of any object has to be perpendicular to the ground, forming that right angle. So the next thing I need to do, so that I know what values to substitute into my formula here, is I need to identify my A, B, and C values because I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, to help me solve